Hi, I am Sanjay Patel. Today we are going to derive some two more theorems about sphere. In the last lecture we have proved that the equation of tangent plane to the sphere at point to the sphere x square plus y square plus z square is equal to a square at the point alpha beta gamma, at the point a alpha beta gamma on it is alpha x plus beta y plus gamma z is equal to a square. If you have a sphere and there is some point on this sphere, say a alpha beta gamma, then the equation of tangent plane at this point is given by this equation. So this is the sphere. Remember, the equation must be x square plus y square plus z square is equal to a square of the sphere. Now in today's lecture, we are going to derive a condition that given plane touches the sphere. Okay, so it is a very important result. Let me write down the statement first. Prove that, just a minute, prove that the condition that the plane Lx plus my plus nz is equal to p, where p is not equal to 0, touches a sphere x square plus y square plus z square is equal to a square is L square plus m square plus n square into a square is equal to p square. Also, the point of contact is given by this coordinates, that is LA square upon P, MA square upon P, and NA square upon P. You must remember this condition and the point of contact coordinates. So remember that here we are given a sphere and a plane. We don't know whether this plane touches the sphere or not. So without finding the perpendicular distance, we have seen earlier in our technique of checking the given plane touches the sphere or not. So without finding the perpendicular distance of the center from the plane and checking whether it is equal to radius or not, we can use this condition to verify whether the plane given touches the sphere x square plus y square plus z square is equal to a square. And not only that, we also have the point of contact. So let us prove this very important result. Okay, I start with this. We know that the equation of the tangent plane to the sphere x square plus y square plus z square is equal to a square. Let me call this as equation number 1, at the point say A alpha beta gamma on it is alpha x plus beta y plus gamma z is equal to a square. So we know that if a point A alpha beta gamma is given, then the equation of tangent plane to the sphere is given by this equation. Okay. Now let me change the. Remember that the point A alpha beta gamma lies on the sphere in this case. Okay, lies on the sphere, and hence it will satisfy the equation of the sphere. So we'll get alpha square plus beta square plus gamma square is equal to a square. Okay, let me write this as equation number 3. Further, if the given plane which is Lx plus My plus Nz is equal to P, say number 4, also touches, or it is also a tangent plane, is also touches the sphere, a sphere given by 1, okay, at the same point, at the point A alpha beta gamma. So I am assuming that this plane is also a tangent plane to the sphere at the same point alpha beta gamma. Then equation 2 and equation 4 must be identical, or you can say they represent the same plane. That is, they represent the same plane. You know, if tangent plane exists, then it must be unique. So equation 2 is our this tangent plane alpha x plus beta y plus gamma z is equal to a square, and equation 4 is the given plane Lx plus My plus Nz is equal to P. We are saying that both the planes are tangent planes at the point A alpha beta gamma on the sphere. Okay, same planes. So if two equations are same, then if two equations are identical, then we can compare their coefficients, corresponding coefficients of the variables. So therefore I can compare, thus comparing equation 2 and 4, we get, so this is the main step, comparing equation 2 and 4, we get equation 2 was alpha x plus beta y plus gamma z is equal to a square. Let me show you again. So this coefficient of x, and here the coefficient of x is L. So the ratio of the corresponding coefficients must be same, that alpha upon L is equal to beta upon m is equal to gamma upon n, and also the constant terms we can compare. So what you will get is alpha upon L is equal to beta upon m is equal to gamma upon n is equal to, the right hand side in the equation 2 is a square, and here the right hand side in equation 4 is p. So we must have these ratios equal. So corresponding coefficients as well as constant terms must be satisfying this condition. They are in the same ratio. Okay, only then this is possible. Okay, so what I want to do next is I can compare each of this ratio, this 1, 2 and 3 with this last term. So we get alpha upon L is equal to A square upon P, and that gives us alpha is equal to L into A square upon P. Okay, the same way if you compare beta upon M with the last term, okay, so let me write this way, and beta upon M is equal to A square upon P, and that is beta is equal to MA square upon P, and finally gamma upon N is equal to A square upon P gives you the value of gamma as N into A square upon P. Okay, so we have got these values. But what is alpha beta gamma? Alpha beta gamma is a point on the sphere. So it satisfies this condition 3. So putting the values of alpha beta gamma in this equation, that is alpha square plus beta square plus gamma square is equal to A square, we'll get the required condition. So but okay, like substituting these values in equation 3, okay, that is alpha square plus beta square plus gamma square is equal to A square, we get what is alpha? It is L into A square upon P whole square, beta is M into B square upon P whole square plus NA square upon P whole square is equal to A square. So if you simplify this, we will get L square, this is A raised to 4, and A raised to 4 is common, so I am writing L square upon P square plus M square upon P square plus N square upon P square, and A raised to 4 is a common factor in all these three terms, is equal to A square. Okay, and now simplifying further, this A square will be cancelled, and I can write this as L square plus M square plus N square, okay, into A square. This one A square will be cancelled, and this P square can write this way is equal to 1. So that gives you the required condition. L square plus M square plus N square into A square is equal to P square. So this is the necessary condition that if a plane Lx plus My plus Nz is equal to P touches the given sphere, then it satisfies this condition, which is the required condition. We are also asked to find the point of contact, but it is already done because we know, we have assumed that the plane, the given plane Lx plus My plus Nz is equal to P, this also touches the sphere at the same point alpha beta gamma. This plane touches the sphere at A alpha beta gamma. So alpha beta gamma is the point of contact, and we already obtained the values of alpha beta gamma here. So I can say these three values gives me the coordinates of point of contact. So I can write directly, and the point of contact is given by A alpha beta gamma, which is nothing but La square upon P, Ma square upon P and NA square upon P. So we approved this result. Okay. So let us take one simple example to understand the application of one or two examples to understand the application of this very important theorem. Let me solve some one or two problems. The first problem, just straightforward, find the equations, find the equations of tangent planes. Find the equations of tangent planes to the sphere x square plus y square plus z square is equal to is equal to say 25 and which are parallel to the plane given by x plus 2y plus z is equal to say 1. Okay. So what is given here? A fixed plane is given, x plus 2y plus z is equal to 1, and the sphere is given. So we have a sphere. We have a sphere like this. And this sphere has center 0, 0, 0 and the radius is 5. Okay. What is the other thing given? Some plane x plus 2y plus z is equal to 1 is given. So let me draw a plane. So some fixed plane is given, and remember this fixed plane is not a tangent plane. The equation of this plane is say this is the fixed plane. We want to find an equation of a plane which is parallel to this and touching the given sphere. So I want a plane which touches the sphere and remains parallel to say this. Okay. And you can understand immediately there will be two planes. One is touching here and the other one I can draw this way. It is touching at the bottom. So there will be two planes. It is clear from the figure. And remember this is the fixed plane whose equation is x plus 2y plus z is equal to 1. So the direction of the normal vector of this sphere, this plane is n bar is equal to 1 to 1. Okay. And you know very well that if we have a plane ax plus by plus cz is equal to d, then the general equation of a plane which is parallel to this is given by ax plus by plus cz is equal to k, which is any real number. Okay. So let me start this way and note one thing, that equation of this sphere is x square plus y square plus z square is equal to 25. Okay. the general equation of a plane which is parallel to the fixed plane which is given to us, x plus 2y plus z is equal to 1, is given by x plus 2y plus z is equal to k. Okay, and k is any real number. If k is equal to 1, we get the given plane. And what is our aim is this plane, arbitrary plane. So there are infinitely many planes, which are parallel to this plane, but we want to find only those two planes which are parallel to the green plane and touching the given sphere as shown in the figure. So we want to find a value of k. Okay, but we know that according to the theorem, that if a plane Lx plus my plus nz is equal to p touches the given sphere of the form x square plus y square plus z square is equal to a square, then what is the condition? Okay, so let me write this way. But the condition, that the plane, I will not write in detail, touches the sphere is L square plus m square plus n square into say a square is equal to p square. We have derived this condition just now. Okay, this one. And remember, what is L, m and n here? L, m, n are the coefficients of this equation of the plane. So I can write this implies I will get 1 square plus 2 square plus 1 square. Remember, 1 to 1. These are the coefficients of this plane, which is, we are assuming that it is tangent plane. And what is a square? A square is the radius of the sphere, that is 25. I mean, a is equal to 5, so a square is 25. And p is the constant term. Here p is equal to k. Here p is equal to k. Okay. So if you simplify, what you will get is say k square here. Sorry, putting p equal to k, will get k square. So we will get 25 into 4 plus 2, 6. 25 into 6 is equal to k square. Okay. So k is equal to plus or minus 5 root 6. So we get two values of k, and putting these two values here, we get the required tangent plane. So let me call this as star. So substituting the value of k in star, we get the required tangent planes. X plus 2y plus z is equal to plus or minus 5 root 6. Okay, and remember, plus sign gives one equation, minus sign gives another equation. So there are two equations and both are tangent planes to the sphere. So this, which are the required tangent planes. These are the required tangent planes. Okay, and in this case, point of contact is again simple. Also, the point of contact is LA square upon P MA, sorry, LA square upon P, MA square upon P, and n into a square upon p. Okay, just recall that here L is equal to 1, M is equal to 2, and N is equal to 1. And A square is equal to 25. And what is P? P is nothing but K, and which we have obtained as plus or minus 5 root 6. Plus or minus 5 into root 6. So putting this value, we'll get two point of contacts for the two different planes. So it is 25 upon plus or minus 5 root 6, comma, m is equal to 2. So 2 into 25 upon plus or minus 5 root 6, and n is equal to 1. So 1 into again 25 upon plus or minus 5 root 6. So this is the point of contact. I am using this formula LA square upon P, MA square upon P, NA square upon P for the point of contact, and just substituting the values. You can simplify further if possible. So it is plus or minus 5 upon root 6 plus or minus, it is 1 5 will be cancelled. So we'll get 10 upon root 6, 10 upon root 6, and here plus or minus, say again 5 upon root 6. So these are the point of contacts. Point of contacts. In the figure, if you want to understand where are these points, it is very easy. And so one point of contact is here, another point of contact is here. And these are the two planes whose equations we have obtained. Okay, so the problem is solved. See, this condition or the theorem, what we have proved in this lecture, we can use only if the equation of the sphere is in the standard form x square plus y square plus z square is equal to a square. But we cannot, we use for the general equation, because it is, or if you are interested, you can derive that condition for general equation of the sphere also. But let me solve without help of that derivation a similar problem for general equation of a sphere. So my question is, find the equations of tangent plane of the sphere x square plus y square plus z square minus 4x minus 2y minus 4 equal to 0, which are parallel to the plane say 2x minus y minus z is equal to 1. So it is a similar question, but for the general equation of the sphere. So let us understand. So we have the same figure, but let me just copy this thing. Okay, and let me remove some. Oh, it is not fair. Let me do it again. Okay, good. Now let us change a little bit. here the fixed plane is 2x minus y minus z is equal to 1. Okay, and this center is also not 0, 0, 0, and equation of the sphere is now different. It is x square plus y square plus z square minus 4x minus 2y minus 4 equal to 0. So what is the center of this sphere? You know how to find the coordinates of the center. Just dividing the coefficients of x, y, z by 2 and changing the sign. So c into, say, plus 2, then this is minus 2y. Let me write it properly. It is minus 4x minus 2y. So it is plus 1 and z component is not there. So it is 0. Z term is not present. So its coefficient is 0. Okay. So this is that. And what is the radius of this sphere? That is also important now. Let me mention here what we have done. The center C of the sphere is 2, 1 and 0, and the radius is given by r is equal to square root of, you know that formula, u square plus v square plus w square minus d. So putting the values of u, v, w, what is u, v, w? We can take this plus or minus anything because there is a square. So this is u, this is v, this is w. Rather it is minus u, minus v, minus w, but squaring will not make any difference. So this minus d, d is the constant term. So it is minus 4. So 4 plus 4, 8 plus 1, 9. So this is equal to 3. So radius of the sphere is 3. So if we join these two, then or these two, this distance is 3, or this distance is also 3. Let me show you by some different color. So this is the radius, and that is also 3. Okay. So now we start the same way what we have done in the previous example. Our aim is to find equations of tangent plane which are parallel to the plane 2x minus y minus z is equal to 1. So the general equation of a plane which is parallel to this is given by 2x minus y minus z is equal to k. Okay. So this is also 2x minus y minus z is equal to k. Let me write that first. The general equation of a plane parallel to the given plane. This given plane is fixed. So given plane 2x minus y minus z is equal to 1 is 2x minus y minus z. These coefficients remain same. Just we write is equal to k, where k is any real number. So let me call this the number 1. Okay. Now we know that if a plane touches a sphere, then the distance of the center of the sphere from the plane is exactly equal to radius. So if I consider this CB or CM, CA or CB, then this distance, this perpendicular distance is equal to the radius. So let me write in a general form. Here, since this plane touches the given sphere, okay, at some point, say at some point, say A, okay, A or B, anything, then we must have CA, the distance of the center, okay, from this point of contact is equal to R, that is radius of the sphere, okay, that is CA is equal to R. What is R? R is equal to, we have obtained is 3. So we need to find what is CA, and you know very well the center coordinates are let me write here, are 2, 1, 0. Yes, it is 2, 1, 0, and we want to find the point distance of this, okay, perpendicular distance from the plane 2x minus y minus z is equal to k. So using that formula of finding this perpendicular distance, say CA or CB, what we can write here is just substitute these coordinates 2, 1, 0 in the equation of the plane. So 2 into 2, we putting x equal to 2 here, minus 1 into y is 1 again, minus 1 into z, that is the z coordinate, and minus constant term. The constant term is k. So it is minus k. This upon square root of what? This a square plus b square plus c square means 2 square plus minus 1 square plus minus 1 square. This is the formula you have done in your higher secondary course. And what is the right hand side? It is 3. So we get this equation. So let me solve this. So this implies 2 to the 4, and 4 minus 2 is 2. Just a minute, this is 0, so this will go. So 2 minus 1, 4 minus 1 is 3. So 3 minus k in mod upon, this is 4 plus 1, so it is 6, root 6, and this is equal to, say, 3. So if we get mod of 3 minus k is equal to 3 into root 6. So if you open this modulus, you will get 3 minus k is equal to plus or minus 3 root 6. Okay. If mod x is equal to a, then x can be a or minus a. So this gives me k is equal to 3 minus plus 3 root 6. If this plus goes on this side, becomes minus, and if this minus goes on this side, becomes plus, taking this k on this side. So k is equal to plus or minus 3 minus or 3 plus 3 root 6. So we get two values, and that gives me the equation of tangent plane. So thus the equation of tangent plane, required tangent plane to the given sphere, okay, R, because there are two planes, so the equation of tangent planes will be, say, 2x minus y minus z. We have taken as k. Now k is equal to this 3 plus or minus 3 root 6. So what we obtain is this, these two equations. This is 2x minus y minus z is equal to 3 plus 3 root 6, and this is 2x minus y minus z is equal to 3 minus 3 root 6. So any one plane you can take with the plus sign and other plane with the minus sign. So these are the two required tangent planes of the given sphere. Okay, so when the general equation is given, we can find the equation of tangent planes which are parallel to some fixed plane. Okay, let me solve one more interesting problem. Say problem number 3. If a plane 3x minus 2y minus 6z is equal to k, let me write p just for touches a sphere x square plus y square plus z square is equal to 49. Then find the value of the constant p. Find the value of the constant p and point of contact. So it is very easy example. It follows directly from that theorem what we have derived today. We know the condition that the plane Lx plus My plus Nz is equal to P. That the plane, let me write down in detail, the plane Lx plus My plus Nz is equal to P touches a sphere x square plus y square plus z square is equal to a square is L square plus m square plus n square into I think it is a square. Yes, it is a square is equal to p square. Okay, so here in our example, the values of L, M and N are respectively L is equal to 3, M is equal to minus 2 and N is equal to minus 6. Comparing this equation with this given equation, and P is equal to P. Okay, and the value of A, that radius, is 7 because this is 49. Okay, so putting these values in this condition, we get L square, that is 3 square plus minus 2 square plus minus 6 square into A square. A is 7 square is equal to P square. So what will you get is 9 plus 4 plus 36 into 7 square is equal to P square. So 36 plus 4 is 40 plus 9 is 49. So this is 49 into 7 square is equal to P square. I can write it as P square is equal to 7 square into 7 square. So that gives me the value of P taking square root on both the sides, plus or minus 7 into 7. Okay, because this you can write, or directly let me write in a simple way, not like this. This you can write as 7 square into 7 square, you can write as 49 square. So it is plus or minus what? 49. Directly I can get the value of p. So putting the value of p here in that, that is the required constant, sorry. And the point of contact is also remaining. So this is the required constant, p is equal to plus or minus 49. And the point of contact is given by, you must remember this formula, LA square upon P, MS square upon P, and NA square upon P. What is L, M, and N? That we have already written here. 3, minus 2, and minus 6. So 3 into 49 by plus or minus 49. Then minus 2 into 49 by plus or minus 49, and n, that is minus 6, I think, yes, it is minus 6 into 49 by plus or minus 49, because the value of p is plus or minus 49. So this gives us cancelling this way, we will get plus or minus 3, plus or minus minus 2, and plus or minus minus 6. So when you take the plus sign, if you take plus sign, we get 3, then minus 2, and minus 6. Okay. And when you take minus sign, you will get minus 3, minus minus plus 2, minus minus plus 6. So these are the point of contacts. So this way you can solve problems based on that important theorem, the condition that a given plane touches the sphere. Okay. So in the next lecture we'll be understanding an important and again interesting result, that under what condition two spheres will be orthogonal to each other. Okay, so you see this lecture again and again because it is very important, and try to solve problems like this. Thank you.